The Met Office posted a message on the 6th of May 2026 that stopped people mid-scroll. Your wardrobe, they wrote, will be kept busy over the coming week, with temperatures fluctuating day to day. It read like a polite understatement, because what was actually happening across Britain at that moment was not fluctuation. It was a collision between two entirely different seasons happening simultaneously on the same island. Scotland was sitting under cold showers and overnight frost. Southern England was reaching 20 and 21 degrees Celsius and sunshine warm enough to sit outside in. And somewhere in between, along the borders and the northern uplands, snow was still falling on high ground in May, while sunbathers were booking garden chairs in Kent. This is not just a quirky British weather moment. This is something fundamentally different from the unpredictable springs that the country is used to. And the science behind what is causing it tells a story that every person living in Britain needs to understand right now. The contrast playing out across the UK this week is so stark that the Met Office described the country as experiencing a striking mix of weather simultaneously. Southern England, particularly eastern areas, and East Anglia, holding on to temperatures of 20 to 21 degrees with good spells of sunshine. Scotland sitting on the cold side of a dividing line that is essentially cutting the country in two, with scattered showers and temperatures struggling to reach double figures. Northern Ireland and Northern England sitting somewhere between those extremes. Depending on which air mass wins the daily battle for control of any given postcode, your wardrobe will be kept busy. That is one way of putting it. The polar blast that pushed temperatures back toward winter values earlier this week arrived on the back of northerly winds driving directly from the Arctic. GB News reported just 5 days ago that Britain's warm spring was about to make a U-turn as bitter polar winds pushed mercury into single digits in northern regions, with the possibility of snow on high ground and overnight temperatures below freezing in Scotland. That forecast delivered exactly what it promised, and it delivered it within the same week that southern parts of the country were recording temperatures more commonly associated with a pleasant early summer afternoon. The same island, the same week, snow on one end, sunscreen weather on the other. To understand why this is happening, you have to understand the atmospheric structure producing it. The jet stream, the fast-moving river of air high in the atmosphere that drives almost all of Britain's weather, is in a deeply disrupted state right now. It is not running cleanly from west to east in the way that produces stable, broadly consistent weather across the country. It is buckled, wavy, and inconsistent in its position. In that configuration, it creates what meteorologists call a sharp meridional flow. Cold air from the north plunges southward down the left side of the buckle, while warm air from the south surges northward on the right. When Britain sits across that dividing line, the south of the country experiences one season while the north experiences another. That is not a weather forecast. It is a description of two different climates sharing the same national borders. NetWeather's Spring 2026 long-range forecast flagged exactly this kind of pattern as a likely feature of May. Their analysis described high pressure becoming dominant close to the east or over the UK, bringing predominantly dry and settled weather, while the Atlantic would make inroads from the west with cooler polar maritime air capable of bringing snow to Scottish mountains. Snow for Scottish mountains in May. That is a specific and accurate meteorological forecast that has been confirmed by the actual weather unfolding this week. The Met Office Fool's Spring blog, published in March 2026, added important context. Statistically, they noted, snow or sleet is more likely in March than in December, and cold snaps remain possible well into April. Even May, they said explicitly, can occasionally bring chilly nights. Late-season wintry weather is not new. What makes 2026 feel different is not that cold air arrived in May. It is that it arrived on the same day that 21 degrees was being recorded 200 miles to the south. The geographic contrast within a single small island in a single week of May is the part that has no modern equivalent in the records. The deeper driver of all of this is the same force that has been reshaping British weather throughout the entirety of the 2025 to 2026 meteorological year. Scientists call it climate whiplash. The Conversation, publishing analysis in March 2026, defined it plainly. Climate whiplash describes rapid swings from one type of weather extreme to another. Globally, such swings have increased in recent decades. Shorter-term whiplashes over just a few months have become roughly a third to two-thirds more frequent. Year-to-year swings have increased by up to a third. In Europe and the UK, these swings are driven primarily by the jet stream, which is being destabilized by changes in the thermal gradient between the rapidly warming Arctic and the more slowly warming temperate zone. The year the country has just lived through is the most complete single-year illustration of climate whiplash Britain has ever recorded. 2025 delivered the UK's warmest summer on record. Then, winter 2025 into 2026 delivered 50 consecutive wet days in parts of Devon and Cornwall. One of the rainiest winter seasons on record. Only 80% of average sunshine. The contrast between that summer and the winter that followed is, by itself, an extraordinary meteorological event. And now May 2026 is adding a new chapter, producing snow and 21 degrees Celsius in the same week, as if underlining the point that the old concept of a predictable seasonal calendar no longer applies. The jet stream behavior producing May's temperature split has a specific mechanism worth understanding. The multiple sudden stratospheric warming events throughout winter 2025 into 2026 disrupted the polar vortex repeatedly. The final warming of the polar vortex, which happens every spring as the stratosphere transitions into its summer regime, occurred in early April 2026. When the polar vortex completes its final warming, it releases the cold air it had been containing over the Arctic into the lower atmosphere, where it becomes available to be dragged southward by the buckled jet stream. That process takes weeks to play out. Right now, in early May, Britain is still feeling its downstream effects. The cold air arriving from the north this week is the tail end of a polar vortex disruption sequence that began in February. These things do not resolve quickly. They resolve on the time scale of atmospheric dynamics, which operates indifferent to the calendar month. Meanwhile, as all of this cold drama plays out in the north, the south of Britain is experiencing conditions that already preview what the coming summer months may deliver. The 20 and 21 degrees recorded in East Anglia and southeast England this week arrive on a background atmospheric temperature significantly elevated above any historical reference point for this time of year. The global average surface temperature has spent 22 consecutive months above 1.5 degrees Celsius above pre-industrial levels. When warm air pushes northward into the country from the continent, it pushes air starting from a warmer baseline than equivalent southerly flows produced 30 years ago. The same pressure pattern produces higher surface temperatures in 2026 than it would have produced in 1996. That is the climate signal embedded inside every warm day Britain records. The practical consequences of this unpredictable spring extend well beyond coat choice confusion. Farmers across England and Wales have spent this spring managing planting windows compressed and disrupted at both ends. Fields too saturated to work in February dried faster than anticipated under April's warm, dry conditions. Now, as northerly winds push temperatures back down and bring heavy showers to northern regions, the soil moisture picture is fragmenting across the country. Fields in Lincolnshire that were too cold and wet last week may be warm and dry enough to plant this week. Fields in Kent planted in warm April sunshine are experiencing temperature drops that put early crops at frost risk. The unpredictability is not just inconvenient, it is economically damaging, and it is becoming the defining characteristic of British agriculture's operating environment. The biodiversity consequences are equally real. The Met Office Fool's spring blog described how environmental cues, longer daylight hours, early flowers, tree buds, and bird activity are the signals the natural world uses to time its seasonal behaviors. When temperature swings produce conditions simultaneously spring-like in the south and wintry in the north within the same week, species that have already responded to early warmth by emerging, breeding, or flowering find themselves exposed to conditions their biology did not anticipate. Insects that emerged early under April's warmth face frost and snow in May. Birds that began nesting on the basis of an early warm spring face cold reversals during the most critical period of their reproductive cycle. These biological mismatches accumulate across seasons and compound across years in ways that ecology is only beginning to document. The Met Office forecast for the rest of May 2026 describes changeable and at times rather unsettled conditions dominating through the middle part of the month, with low pressure often close by and periods of rain or showers. Temperatures likely to be close to or a little below normal for much of the period, winds often blowing from a northwesterly quadrant. Towards the end of May, the forecast shows a signal for more settled weather developing, with longer spells of fine and dry weather possible as pressure increases toward the southwest. That pattern, unsettled and cool through mid-May, followed by a gradual shift toward more settled, warmer conditions as the month ends, is consistent with the seasonal transition from the disrupted polar vortex influence toward the summer circulation pattern that El Niño is building in the Pacific. The transition is not clean. It does not happen all at once across the whole country. It happens in lurches and reversals that leave the daily forecast genuinely uncertain. Britain has always had variable spring weather. That is not the story here. The story is the degree of that variability, the geographic scale of contrasts within a single island, and the rate at which the climate system is amplifying them. Snow on Scottish hills and 21 degrees in East Anglia in the same week in May is not just a quirky anecdote. It is a data point in a pattern that every credible climate institution in the country is tracking and describing in the same terms. The swings are getting sharper, the contrasts are getting larger, and the season supposed to bridge the gap between winter and summer is becoming the most chaotic and unpredictable period of the entire British meteorological year. Your wardrobe will indeed be kept busy. Just do not expect that to change anytime soon. There is one final layer to this story that goes beyond the immediate forecasts and the weekly weather drama, and it concerns what the science is telling us about the direction this pattern is heading, not just this May, but across every spring season that follows. The Climate Change Committee, the independent body that advises the UK government on how climate change is reshaping the country's risk profile, is due to publish its next major risk assessment later in 2026. It will arrive after what has been one of the most extreme 12-month weather sequences Britain has recorded in the modern era. The warmest UK summer on record, one of the rainiest winters, an April that swung from 26 degrees to ground frosts in a matter of days, and a May that simultaneously served two different seasons to the same island. The assessment will land, in other words, into a country that has been living the evidence of what it is about to describe. The Conversation's analysis of climate whiplash made the policy implication explicit and direct. Policy is still largely designed around averages, yet the weather is behaving less and less like an average year. If the UK is heading for an era of sharper swings between flood and drought, of colder cold snaps and hotter heat events arriving in the same season, policymaking and adaptation systems will need to catch up with a climate that is no longer producing what the historical baseline predicted. Infrastructure designed for average rainfall cannot handle 50 consecutive wet days. Agriculture calibrated for average spring temperatures cannot manage snow in May and 22 degrees a week later. Insurance frameworks built around historical risk models cannot price the volatility that climate whiplash is now delivering as a routine feature of the British seasons. The economic consequences of this unpredictability are already measurable. Rail lines submerged during winter floods appeared only months after summer drought had caused nearby lines to buckle as underlying soil dried out. Energy suppliers managing demand forecasts, supermarkets managing seasonal supply chains, local authorities managing road maintenance budgets, emergency services managing unpredictable events, all are operating in an environment where historical weather data no longer describes the climate they are actually experiencing. The scientific explanation for why British springs are becoming the most volatile season of the year is not complicated once you understand the basics of how a warming Arctic changes the behavior of the jet stream. As the temperature difference between the Arctic and the mid-latitudes shrinks, because the Arctic is warming 4 times faster than the global average, the pressure gradient that drives the jet stream in a consistent, powerful, westerly direction weakens. A weaker jet stream meanders more dramatically. It buckles further north and south of its average position. It allows cold polar air to push further south, and simultaneously allows warm subtropical air to surge further north. The result is a more extreme version of what Britain is experiencing right now. Bigger temperature, contrasts across shorter distances, more violent transitions between weather types, sharper and faster swings between the seasons as each air mass wins and then loses its temporary dominance. None of this will produce consistently warmer British springs. That is perhaps the most counterintuitive aspect of what climate change is delivering to the UK. The country is getting warmer on average, but it is also getting more volatile. A volatile spring that produces 22 degrees in East Anglia and snow in Scotland in the same week is not one that the farmer, the festival organizer, or the emergency manager can confidently plan around. Britain is a small island in a big, changing atmosphere. The season supposed to make sense of the year is currently making the least sense of all, and the data says that before it gets more predictable, it is going to get considerably more surprising.